Hello, I'm Maitri Saraf, first year BTech student at IIT Mandi. In this video, we are going to discuss one of the most popular string matching algorithm, not Morris Pratt or simply Kmp algorithm. So let's get started. We know what an algorithm means, right? It's basically a set of rules or instructions to be followed by a computer to perform calculations or solve problems. The advantages of algorithms are as follows. String matching algorithms. What they really are. As the name suggests, these are used to search a string within another string. Some example of string matching algorithms are as given. Out of these, we are going to discuss the knife string matching algorithm and the KMP algorithm in detail. We might think, what's the use of string matching algorithms? These algorithms are used in some commonly used software like Word, MS Word, Notepad, etc., in search engines, and the list goes on. Okay, here our objective is we are given a text T and a pattern P in the form of array. We need to write a search function that prints up all occurrences of pattern in our text. We have given length of text is n, length of pattern is m, n greater than m. We should get the index number where the pattern is found in the text. Before moving on to KMP algorithm, let's take a look at the simplest string matching algorithm, that is the naive algorithm. Naive algo compares all characters of main text with pattern. What we do is we slide our pattern over the text, that is, we match first character of pattern array and text array. If they match, we check next characters, otherwise, we again match first character of pattern array with the next of text array, and so on. If we reach end of pattern, it means the pattern has been found. Let's consider an example. We have text IIT Mandi, pattern end. Let's take two variables I and j that point position of indices of array t and p respectively. We compare them. We see there's a mismatch. This goes on, so we keep increasing values of I, keeping j at 0. We compare now. I5, J0, they match. We increase both I and J by 1. We compare them again and again we see they match. So we increase I and J both by 1. Now we have reached end of our pattern array. So text has been found at index I minus J, that is 5. Let's look at another example having repeating letters. We consider variables I and J as before and compare. We see they match. We keep on increasing values of I and J. Now, when I is 3 and j is 3, there is a mismatch. So, we move j back to 0 and I back to 1. And we start comparing them again. We keep on increasing values of I. Now, we see that when value of I is 3 and we start comparing again j from 0, we see that a pattern has been found in the text. Pattern is found at index I minus j, that is 3. But here there's a problem. Even if we know that some of the letters of P repeat after a mismatch, we again backpress I in our main text, comparing even those elements we already did before. These extra steps reduce efficiency of algo and thus increase the time complexity. Let's look at best and worst case for this algo. Best case is when a pattern does not occur in text. A pattern pouring does not occur in coding is 1. Number of comparisons in best case is big O of n. Worst case is when characters of text and pattern are same or only last character is different. Pattern we see here pattern occurs in text multiple times consequently and we check those repeating characters again. We make m comparison for n minus m plus 1 times. So we get our time complexity as big O of m into n minus m plus 1. To make string matching algorithm more efficient, we use KMP algo. It checks the characters from left to right. When pattern has a pattern within pattern, or rather say sub pattern, we use KMP algo. It is suitable even for longer text. Its time complexity comes out to be as big O of n. The KMP algorithm has two components. First is the prefix function, which tells how pattern matches against shift of itself, and second is the KMP matcher that finds occurrences of pattern in the text. First, let's take a look at the prefix function, or say LPS, by taking some example. Let's take variables j and I beginning from 0 and 1 respectively. We initiate another array known as LPS having same length as our pattern array. With LPS of 0 as 0, we compare j and I. We see they match. So we store j plus 1 in our LPS array and increase both I and j by 1. We compare them again. We see there's a mismatch. So we take j back to 0 and compare them again. We see mismatch, we store j, that is 0, in our LPS array. Now we increase I by 1. We again compare I and j. We see they match, so j plus 1 goes in LPS array. We again increase I and j by 1. We see they match, j plus 1 goes in our LPS array. This goes on. We keep on increasing values of I and j. Now when value of I is 8 and j is 5, we see there's a mismatch. So we take j again back to 0. We compare them again, we see there's a match. So here j plus 1 goes in our LPS array. We again compare I and j by increasing I by 1. We see they match. J plus 1 goes in the LPS array. So now we got our LPS array. Let's summarize our algorithm to calculate LPS array. We take length of pattern PM as length of our LPS array, take LPS of 0 equals to 0. We initiate J from 0 and run while loop for values of I 1 to M. If pattern of I and J match, we store J as LPS of I and increase both I and J by 1. Else, if j is not equal to 0, we store LPS of j minus 1 in j. Else, if j equals to 0, we take LPS of I as 0 and then increase I by 1. Thus, we obtain our LPS array. Now, let's look to a previous example, but this time using Kmp algorithm. We have our text, we have our pattern, and we generated the LPS array from the algorithm as discussed before. We again take two variables, I and j. We compare text and pattern. We see they match. We increase values of I and j. Now we see there's a mismatch. So we take j back. So we look for corresponding element for j in the LPS array. We see we have 0 as at third position. So we move our j back to 0th position. We again start comparing them, and we see as we keep on increasing values of I and j, our pattern has been found at index I minus j, that is 3. Now, we observe here that we have only increased I in forward direction. We never traced back I. We only shifted j in the backward direction. But where to trace back j? Here, LPS array comes to a rescue. We look for the corresponding element in the LPS array for which for which there is a mismatch. So we move j to that position in our pattern array. So now let's summarize our KMP matcher algorithm. We have n as length of our text, m length of our pattern, and we generate LPS array from the LPS array generation algorithm. We take j from 0 and run while loop for values of I from 0 to n. If pattern of j and text of I match, we increase both j and I by 1. If we reach the end of our pattern array, that is j equals to m, we print in found pattern at index I minus j and then store LPS of j minus 1 in j. Else, if pattern of j and text of I do not match, and if j is not equal to 0, we store LPS of j minus 1 in j, and else we increase I by 1. Now let's take a look at program written in C++ with the help of Kmp algorithm. We see here we have a program for generating our LPS array, and this this is the code written for Kmp matcher. This is our main program. Let's run it. We see found pattern at index 3. So here we come to the end of this video. Thanks for watching. Hope you like it.